So yeah, today I'm just going to do sort of a brief overview of some layer two thoughts that I have. And I'm not going to give an overview too much of Fuel or what we've been working on. For what it's worth, we launched an MVP of our UTXO-based optimistic rollup in December of 2020. And 2020 just like goes by. The year doesn't even count for me anymore. So I just forgive me. December of 2020. You know, the idea behind it was really for our team to be able to actually see if we can ship an optimistic roll up, even if it was very basic. So Fuel, you know, is taking a different path from the EVM and where everything's going right now. And we're an optimistic roll up that is focusing on processing and specifically trying to address some of the processing problems of Ethereum. And you can think of our project as not afraid of trying something new or different, even if, you know, even if people might not use it. We are kind of going in that direction, but we do think people will use it. So essentially today, I just wanted to go over though some of the pain points of processing with Ethereum, processing the EVM, and kind of why a project like Fuel needs to exist, and particularly why we should be thinking about the way that we handle computations with blockchains. And you guys can hear me fine? We're all good? Not breaking up or anything? Zoom is handling me fine?
Yeah.
All right, good. Okay. All right, cool. So where are we now? So in the current landscape of things, Arbitrum, I think, is going to launch today. I'm pretty sure it's supposed to. I don't know if it has yet. I'm off Twitter now, so trying to live my life outside Twitter. You know, right now, in terms of layer twos, you know, Arbitrum for me is the best you're going to get with a layer two on Ethereum. So it's going to be the closest to the EVM. Architecturally, they're going to achieve what I would consider to be the best processing results if you're going to do the EVM again. And you know, there's also been some application-specific layer twos that have been launched. There's been some privacy-preserving layer twos. There's a lot of ZK stuff on the way in terms of general-purpose smart contracts. Obviously, transferring, swapping, doing basic, you know, swapping pairs and stuff like that. Sure, that's available, but in terms of general-purpose ZK rollups and these sorts of things, they're all on the way, not here yet. And then, of course, we launched our little MVP UTXO rollup as well. So this is sort of the state of things of where we're headed. And of course, optimism as well. But again, I think in terms of my purview, if you're going to do the EVM again with layer two, and you're going to do that on Ethereum, Arbitrum is going to be your best design choice, your best bet. So the way that they put things together is so as close as you're going to get to what you want. Now, how do we get to this whole system of layer twos? Like, why do we even need layer twos? Why are we here? And why can't Ethereum just scale? So this is something you might ask yourself. So essentially, Ethereum can't just magically scale because it has processing bottlenecks. And it has processing bottlenecks over the fact that we have some constraints. Ethereum has a 2-week sync constraint, or about 2 weeks. And essentially, you want it to run on normal computers. You want a peer-to-peer network to run on normal hardware. And you want it to function in a way that can take up a bit of computing power, but can ultimately run normal stuff across the internet and not take too long to sync. If it takes 3 months to sync, who the hell knows if it's actually valid? Actually getting to that reality could be difficult, and actually getting up to sync can really suck. So you put these constraints on it because you want the network to be real, you want it to be decentralized, and you don't want it to take forever to validate and process. So when you add those constraints in, you can't just do anything. You have to restrain the processing that's going on in the blockchain. But particularly, anything that goes wrong in your design creates a bottleneck. And with Ethereum right now, the main bottlenecks are really around serialization and processing, particularly around state serialization, accounts serialization, and general processing problems that happen when you kind of go through the way the EVM processes. So to highlight some things, just to get your mind around, a little bit about, and this is just me ranting in a single slide. There's a lot more than this, but these are some highlights, EVM highlights of bad processing. The accounts model requires nonces and global serialization, and it affects the way you use random access memory, such that essentially you need to process everything in serial, which really sucks. And I'm sure ChainSafe knows all about processing large volumes of transactions in serial due to these sort of designs. So inherently, you can't parallelize the processing. The EVM, for some reason, uses 256-bit words, which, oh, by the way, are we still good? Can I get a sign of life? Okay, sorry. It just every frame froze, and I was like, "Uh-oh, am I talking to myself?" Okay, good. Just let me know. Someone scream at me if it's not working. So the EVM uses 256-bit words. This was not a good choice. We didn't need to do this, and ultimately this affects the way that the maths work in the system, and can represent some significant overhead in terms of mathematical processing. As well, using 256-bit words in the encoding schemes is also extremely baggy. There's an inefficient memory and state model. So the way that memory is handled across frames sucks, and the way that the state model processes is really horrible. And I'm sure if you've had to do an implementation of Ethereum, you kind of know this. GASA accounting is improperly priced, so state is underpriced, and things like normal logical operations are extremely cheap, and certainly there could be some repricing that needs to happen. Essentially, state needs to be repriced for sure, and memory is oddly priced and not appropriately allocated. When you get into just the general processing model of having to process Ethereum transactions, because of the random access issues, you essentially have to process every transaction in serial. And if we're going to handle the world's volume through Ethereum, can't be through a serial process. So that was a little dumb as a design decision. There's a lot of legacy baggage. I don't need to go into it, but essentially just little choices about the way that jumps work and call frames work and other things ends up causing a lot of problems, both in the implementation side, the auditing side, and the processing side. Everything in Ethereum is a call or a contract, and there's no scripts. This generates a lot of state that's sort of useless. So a lot of times you just want a multi-sig for one use, and you can't do that. For example, ERC20s suck and should be native. So the fact that ERC20s are basically re-implemented accounts model contracts using state in Ethereum over and over again is kind of insane, that causes a significant amount of overhead when you're doing processing. And we can go on. So if you want to put all that into a rollup, you can, and it certainly will seem to alleviate things for a while, and that's fine. You can put it into a layer 2, like Optimism or Arbitrum does. You could try to put it into something that is abstracted into a ZK rollup. But ultimately, you still have to do the processing somewhere. You still have to do it, and it doesn't really solve much. There is some nice little things you can do in the meantime if you just want it to be really cheap, is you can just create another layer 1, or you can create a side chain. So this does change the underlying security profile of what you're processing and what you're transferring. It requires bridges and other things from layer 1 to layer 2, or sorry, layer 1 Ethereum to layer 1, whatever. For what it's worth, I like Polygon and XDAI. I think they're pretty cool projects. And I think it shows that people just want it to be cheap, and they'll, let go of a certain amount of security just to get the sort of activities done that they want to get done. And most of the people on Ethereum right now, a lot of them care about security, but they've been getting it sort of for free. And I think ultimately, if they take a bit of risk, jump into Polygon, do a bunch of trades, sit there for a while, and then come back maybe later. They don't inherently mind that. So, right now I think the user base is sort of okay. Okay. Hey guys, sorry, I'm joining on my phone because I think my internet just dropped. The Wi-Fi around here is pretty bad, but I thought
California was great.
It is. Everything is great except in Long Beach. The internet around here is just god awful. It's just awful. So there's a trade-off with everything.
Well, you might have the trees, but we got the internet. So
yeah, that's right. I really want my like T1 Toronto line back. That was really great. All right. So can you guys still hear me, see me?
Yeah, we got you perfectly.
Yeah. All right, great. All right, so phone to the rescue. So yeah, essentially just to finish off, my presentation, because essentially there was only 2 slides left. So, you can go to a layer 1 or a side chain. Ultimately, if you want to change the way things process, the EIP process tries to do that, and it tries to do it in a way that is obviously democratic and working through everything and making big, hard changes, which are sort of required to fix a lot of these bottlenecks. I don't think we're going to see for quite a while. I think things around the periphery that might be easier are things like making ERC20s a little more native in processing. But ultimately, as a person, I'm incredibly frustrated and sick of looking at the EVM because I've been looking at it for 6.5 years. And I think Ethereum, as much as the EVM and Solidity have been a tremendous part of Ethereum and the growth and development of Ethereum to me is much more than just the EVM and Solidity, as much as people would like to fixate on those things. And Ethereum can be used as a base arbitration layer for whatever execution layer you want. You don't have to do the EVM again. And so it's a great starting point for this sort of journey into, into sort of the next realm of, of doing blockchains. But ultimately, you have to ask yourself the question, if you did propose something different, would people use it? Would volume, go to it? Is it going to be good enough to really switch off the existing tooling? And, is the thing you're switching to really right? Or is Ethereum and the EVM as it currently stands sort of good enough? And so ultimately, all of these thoughts are valid. And I think it's very exciting what's happening in terms of both layer 2. Again, as far as my admiration goes, it's definitely for the Arbitrum team. It's my fanboy layer 2 pick if you're going to do EVM. Polygon and XDAI are really interesting in their own right. But for what we've been working on the fuel side, and a lot of it has been private since our last release, just because we want to build up some momentum technologically, is really to try to solve some of these processing problems, bring a different kind of experience to using these blockchains, and ultimately try something different with Ethereum than what's sort of going on. And the hope is that it's worth it for the learnings, but also that I think a lot of other blockchains would benefit from seeing some experimentation here and not just recreating the EVM over and over again and trying to reuse the Solidity tooling over and over again. Because as we all know, if you've tried to ship something with Solidity in the past 6 years, how stressful was it? Just ask yourself that simple question. How awful was it for you to do that? And it's taken us years to build up an understanding of the EVM. It's taken years for us to learn Solidity and the ins and outs of it. But ultimately, it kind of still sucks. And I think we can always do better. So, we'll be releasing a version of Fuel that should hopefully accommodate for some of these things in the 3rd quarter. So stay tuned for that. And, as well, we will be doing some sort of private show and tells of our tech and trying to get some feedback from great senior engineers. So I'm sure ChainSafe would love to see all that stuff and probably invite you guys to all of that. I'm a little more cryptic about our stuff, but it's only because the space is so effing competitive. If I went and told you all the processing techniques we're using, I bet teams would pick it up in 2 seconds. So yeah, that's the sort of end of my presentation on layer 2. You know, a side rant on layer 2 scaling, you could say, and where I think things are going and what I think is exciting about the space. So I don't know how much time I have left, or, you know, if we, how much time was I supposed to talk? We can fill it up with questions.
So yeah, we could take questions now. If anyone has questions, feel free to unmute yourself or just drop it in the chat.
Awesome.
Noob question. Oh, go ahead.
Cool. You go first.
Noob question. What is a ZK? ZK.
What is a ZK? Oh, I was just short forming zero knowledge proof. So zero knowledge, like a zero knowledge layer 2 or a zero knowledge, you know, roll up. So the alternate technique to optimistic roll up. So I'm assuming a lot about the technical understanding of people in this in the room. I apologize if some of this just went over everyone's head, but I have a basic idea that maybe you guys understand some of the current happenings of layer 2 and optimistic rollups and ZK rollups. But to go over that just briefly, with Ethereum, there's 2 predominant techniques right now to give Ethereum a little more throughput, a little more room without changing the underlying security of Ethereum. So one of which is an optimistic rollup, and the other one is a ZK rollup. And there's debatable properties of both, but both are what we consider layer 2. And in the ZK side, what you're doing is you're taking the processing and verification and you're putting that through ZK proofs and circuits, and then you're putting a proof on chain, or you're running a proof on chain, and that is sort of you know, you could say you're sort of moving all that computation and verification off chain, and then you're just using Ethereum to sort of sign off on these changes of state. And so, you know, ultimately, again, you're using Ethereum as sort of the grand arbitrator. And this is sort of the predominant theme. In the optimistic category, you basically use a, you know, a game. So you play a game over processing. All of the data for transactions is dumped onto Ethereum. And only when there's a problem do you actually run specific, you know, parts of the execution on Ethereum. So it'll also be, you know, operatable on Ethereum. And then, you know, only if there's a problem do you actually need to go to Ethereum really to do any processing. There's trade-offs and benefits for both. Everyone has their pick and their favorite in terms of which they like. But the optimistic rollup has some nice properties of, we can get extremely close to pure processing. So the operations that go on in our system off chain can basically go right down to the CPU and almost be completely unbothered. Whereas with a ZK rollup, you know, you have to go through a very complex proving system and requires a lot of ASICs and a lot of PhDs and a lot of experimental cryptography to get those results. So I think ultimately I'm a big fan of the ZK rollups and ZK tech, but I'm more of a fan of it for privacy than I am a fan of it for scaling. But that's just because I'm an optimistic roll developer, so I'm biased.
Also, yeah. I'm not sure who asked that question, but we had Mark a couple meetups ago, so 2 months ago, from Optimism, who talked more generally about rollups as well. So that's on our YouTube channel if you are interested in just general rollup information as well.
Yeah. Awesome. Other questions?
Yeah, Antoine had a question. Ask yourself.
I'll ask. So actually, you dropped a few things while you were talking about ranting about the EVM. So I wanted to get the hate out of you and then like put it in display for everyone to see. You mentioned that you thought that gas costs were not properly charged. Like there was a big discrepancy between state operations not costing enough. Can you tell us about that? And to kind of go with that, there's recently there's been a disclosure about broken meter. Have you heard about this? Do you have a take on that? Did you read that?
So I'll admit that I spend a lot more of my time right now at a higher level, so I'm not paying attention too much to some of the recent happenings. That's John Adler, our other co-founder's job. He's the one who will be on Twitter yelling about things that happen right away. I'm off Twitter, trying to stay away from all of this. So that's my admission to you. But in terms of the general problems of state, so with blockchains, state is really one of the most expensive things to, keep track of, process, hold on to, and use. And with, Ethereum's current state, we're using a tremendous amount of state. I forget what it is. I think it's like we're using 180 gigs or something of state right now, like some enormous amount. And the problem with state is that it needs to be sort of readily accessible to be processed quickly. And you need to sort of have it on hand. And because of the way Ethereum state model works, you have a system where you don't really know when you process a transaction what state it's going to touch where. And this causes a random access bottleneck where you end up having to process everything in a serial process. And ultimately, there are EIPs and things to try to attempt to address this, but unless you mandate a processing model that solves it, you really aren't going to get significant benefit until you actually mandate something across the whole chain. If you mandate something across the whole chain, then everyone needs to change the way everything processes, and that's a big deal for Ethereum in a legacy system. But it essentially just comes down to state needs to be easily accessible. It isn't. If it isn't, causes problems. So when you have a lot of it and when you have to go grab it, it's a big issue. But more importantly, when you write to state with Ethereum, we need to provide the, this is just for everyone. I know, Antoine, you already know all this. When you need to, you need to provide not just the rights to state and what the state is, but you need to provide cryptographic proof. And Ethereum uses a global Merkleization system to do this. And ultimately creating these Merkle proofs, storing them for every state, right, and usage becomes extremely problematic when you have a global state model and you have to process everything in serial. So not only is it like, compounded by the fact that state is just expensive and needs to be readily accessed, but that's this re-serialization and re-Merkleization of everything that ends up causing these processing bottlenecks and making it so expensive. And ultimately, when Ethereum was made, they didn't really know where their processing bottlenecks would be because those benchmarks weren't really done because no one was using Ethereum. So essentially, the original prices were set to sort of assume some things about processing based upon best guess, but and some things have been changed, obviously, in terms of state price. But really, if you really get down to it, given where the bottlenecks are in Ethereum processing, it should be magnitudes more expensive to write to state and magnitudes more expensive to read from state, and it's not. And when it's not, then people will advantage it too much in the wrong way and ultimately cause processing issues. So it's an unfortunate side effect. So state pricing is really one of the major problems of gas pricing in Ethereum. But there's of course other things in terms of the way that Ethereum processes memory, processes call frames, processes jumps, processes all sorts of things that don't properly get at the current way that CPUs work. And when you make everything into 256-bit chunks, you really you're just really causing issues because CPUs are 64-bit and you're dealing with 256-bit. So now it's like things are madly more complex in terms of processing and ticks. And so so for Fuel, and what we do with our processing is we just say fuck it. A real engineer wants 64 bits because 64 bits is what CPUs do, and everyone else can suck it. And we should probably change. Yeah.
Interesting.
But that's my rant, and I don't know if we'll win it, Anton. So,
So
yeah.
sorry, we added another link as well from Willem, who also gave a talk about rollups. So we have a lot of rollup content for those. It's definitely something that I think is one of the most exciting things going on in the space right now, in that it's unlocking a lot of scalability, which is something we've been talking about for a very long time.
Yep, absolutely. Also, for what it's worth, for people who are interested, you know, with Ethereum 2.0, because a lot of the questions I get are you concerned about Ethereum 2.0 and sharding and the sort of next phase for Ethereum? And the answer is that the way to scale Ethereum 2.0 is still rollups. So no, it's just you get rollups over shards, and shards, you know, give you more, you know, optional throughput. But ultimately, as we've seen, liquidity only favors certain areas, and cross shard liquidity is still going to be something that's problematic. So you're still going to have issues there, and you're still going to want as much throughput out of a single shard as possible. And you're still going to be back to likely the same issues that we have now. So again, all these things, nothing goes away because you just want to magically make it go away. It just doesn't. Yep.
Sweet. Thank you. Thank you for that amazing talk, Nick. Really
Awesome.
appreciate it.
Awesome. We're also hiring good senior engineers, particularly people who like Rust or who just like good computer science. And if you like low meetings and, you know, very intensive computer science oriented discussions and a lot of trolling, you know, definitely let me know. So yeah, not to poach any ChainSafe engineers, but you know, if there's any bored ChainSafe engineers, I'm not going to turn you down if you apply. And also, yes, you do get a free Nintendo Switch when you join us, because we're very oriented around Nintendo for some reason. Okay, that's it.
Cool.
Thank you, everyone.
Chill. Got to get the chill in.
Just need to chill a little bit.